Hey guys, in this video we're going to be continuing with our probability theme, and more specifically in this one we're going to talk about something called the counting principle, and we're going to make some tree diagrams. So let's go ahead and get started. First thing, we need to define one term, and that is called the sample space. So sample space is just all of the possible outcomes that could occur from a given experiment. So the one that we've talked about recently is the rolling like two dice. So if you were to roll two dice, well, we practice listing out all of the possible outcomes. You get a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, so on and so forth. You get a 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5. So all the possible outcomes, that's called the sample space. Another example would be like if you flipped a coin. Well, that's a pretty easy one. Sample space of flipping a coin is only heads and tails, right? No other options. So depending on what your experiment is, all of the possible outcomes that could occur would be the sample space. We're going to display the sample space using something called a tree diagram. It is just a visual display of the sample space. An example of one looks like this. Here's the possible outcomes. It looks like these would be like ice cream sundaes or something. You've got vanilla, chocolate, and strawberry, 3 flavors of ice cream. You could also add fudge or caramel to either of those. So we could do vanilla with fudge, vanilla with caramel, chocolate with fudge, chocolate with caramel, strawberry with fudge, and strawberry with caramel. And then you could also get sprinkles or chocolate chips. So you could do vanilla fudge sprinkles, vanilla fudge chocolate chips, vanilla caramel sprinkles, vanilla caramel chips, and so on and so forth. So all the possible outcomes here would be sort of these put together. So you could have a vanilla fudge sprinkles, vanilla fudge chips, you have vanilla caramel sprinkles, vanilla caramel chips. So you can list all of these. And we can count how many they are pretty easily. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we know there's 12 possible outcomes. So let's say, what's the probability? If I ask you, what's the probability of getting chocolate and fudge? So, well, we could look at our chart here. Chocolate and fudge would be here. Well, there's 2 that have both chocolate and fudge. The one's chocolate fudge and sprinkles and chocolate fudge and chips. So there's 2 possibilities, 2 favorable outcomes out of the total sample space, which is 12. So 2 out of 12 or 1 out of 6. Getting chocolate and fudge. So this tree diagram is just a way of visually displaying all of the possible sample spaces. We then could compute some probabilities based off of that. Okay, so let's go ahead and draw a couple. We're going to draw some tree diagrams. First one for flipping 3 coins. So sometimes it helps to have sort of like columns when you do this as well. So you got your first flip. What are your 2 options first flip? Well, you could get a heads or you get a tails. We're going to leave a good amount of space there. Okay, then you've got your second flip. Well, your second flip, you could have a heads and a tails as well. So from this heads, you then could either get another heads or you could get a tails, right? And then from this tails, you could either get another heads or you could get a tails. That's your second flip. And then your third flip, each of these, you could roll a heads and a tail as well. So you could do heads, 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 tails. You could do a heads, tails, heads, heads, tails, tails, a tails, heads, heads, a tails, heads, tails, a tails, tails, heads, or a tails, tails, tails. So then our sample space, well, we know we'd have 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 possible outcomes. We would just sort of trace the tree for each one. So we could have heads, heads, heads. So that would be part of the sample space. Oops. We could do heads, heads, tails, So we can make a list of all of these, right? We could do heads, tails, heads, heads, tails, tails. So those are the first 4, and you can list out all of the possible sample spaces. For just the tree diagram part of it, you just need to draw this. Okay, let's try another one. Rolling a die, flipping a coin, and then choosing a hand, so left or right hand. So if these were your sort of your 3 actions here. So the first one, rolling a dice. When you roll a dice, there's 6 possibilities, right? You're gonna need a little bit of space for this one. 2, 3, 4, 5, 6. Might run out of space with that 6. All right, so roll a dice. You get 1, 2, 3, 4, 5, or 6. All right, then from each of these, you flip a coin. So a coin could either be heads or tails. So each of these are going to get a heads option or a tails option. And then from each of those, so let's say without the coin, on your sheet of paper, you can have a little bit more room there and make it better than mine. So from there, you have to choose a hand. So we're just going to say left or right hand. So we could do right or left, right or left. Should have made a little bit further over. Right or left, right or left, right or left, right or left. You get the idea here. This is how it would work. Gets a little monotonous after a while, right? But we could then also can do the sample space on this relatively easily. You could then calculate probabilities as well. For example, we could say what's the probability of getting a 3, then a heads, and then left. Well, there's only one that's 3 heads left. So it'll be 1 out of the total sample space here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 24. So 1 out of 24 chance of rolling a 3, then flipping the heads on a coin, and then choosing the left hand, whatever. Okay. Let's do one more. This time we're going to create an outfit. I've got 3 shirt options. Oh, another thing when you do these tree diagrams, if you want to, some people like to sort of just bring these all together to one point. It makes it a little bit more cohesive. You're welcome to do this if you want to. Just use like a dot there, or some people even write like whatever the topic is. So like on the next one, if we wanted to, like, let's say write outfits. Some people like to do this. It's fine. There's no one right way to do it. So their outfits, we've got red, blue, or green options. So this is shirt. We've got 2 options for pants. We can do jeans or khakis. So pants, jeans, or khakis. You can also abbreviate if you want to. If you wanted to say J and K. J, K, if you want to do that. And then the last one, we've got shoes. So then we just need to write shoes. And we've got tennis shoes or boots, T or B. T or B. So that is the gist of it, guys. Not terribly difficult to draw these. Just try to make it fairly neat, make it neater than mine are. All right, and the last thing we're going to talk about is the multiplication rule of counting. So it turns out there is an easier way to do this. The tree diagrams are helpful, and you need to know how to do those. But sometimes the numbers are even too big. Like, I don't know, what's the chances of you like drawing the correct number 1 out of 100, and then drawing the ace of spades, and then rolling a 7 out of 2 dice? Something like that. So in that case, or just a lot of cases in general, we need some little easier rule. And you might have figured this out already. We can figure out the number of possible outcomes. So this sample space here at the end, and this one, there's 2, 4, 6, 8, 10, 12. So there's 12 outcomes. There's a little bit easier way to do this. It's pretty simple. Here's our formula. The outcomes is just n sub 1 times n sub 2, dot, 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 all the way to times n sub n. So this is just, what they stand for is outcomes for event 1 times the outcomes for event 2, so on and so forth, dot, 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 times the outcomes for event n. That just means you could do this for, doesn't matter if you have 3 events happening or 7,000. You just multiply the number of outcomes for each one. That's all there is to it. So if we were to go back and look at these, this one would be, well, we got 3 shirts times 2 pants times 2 shoes. 3 times 2 is 6 times 2 is 12. Boom, got it the same way. If we went back to this one, rolling a dice, there was 6 times flipping a coin. There's 2 options. Choosing a hand, 2 options. 6 times 2 is 12, times 2 is 24. 24 outcomes. So it is very simple. Let's answer a couple more questions using this. So let's say you go to a fancy restaurant. They have some options called a prefix menu, where you have like set options you can choose some from. And let's say you've got 5 choices for appetizer, 8 entree choices, and 4 dessert choices. So how many combinations does Joe have to choose if he must choose one of each? Well, it's pretty simple. The number of outcomes is simply the product of those 3 numbers. 5 for the appetizer times 8 outcomes for the entree times 4 for the desserts. 5 times 8 is 40. 40 times 4 is 16. So 160. So 160 different meals you could theoretically design from those three things. All right, and one more here. For your second semester schedule, there are 3 different math classes to choose from. So 3 times 2 science classes, 2 English courses times 2, times 1 government course, so you got to choose that one, and 4 electives. So we just multiply them all together. Doesn't matter if there's, again, 3 or 5. You do it the same way regardless. And let's see what we'd get. 6 times 2 is 12, times 1 is 12, times 4 is 48. 48 different outcomes to choose from for your class schedules. All right, that about does it, guys. Good luck on that, and reach out to me if you need any help.